Our next lesson is a little bit out of sync with Engage New York. It best aligns with lesson 37 of Module 1 in Engage New York. But there are some ideas right here that we want to discuss that are helpful for us in our discussions about solving polynomial equations. So in this video, we're going to introduce something called complex numbers. Now, complex numbers have a bit of bad marketing, okay, because they sound a lot more challenging and complex than they really are. Okay, and the other way to talk about them is as imaginary numbers, which isn't any better. So either way, they kind of have some bad marketing. But anyway, in this video, we will review numbering systems and talk about what complex numbers are. We'll talk about how to take the square root of a negative number using complex numbers and imaginary numbers, and also how to add, subtract, and multiply complex numbers. Let's get started. Okay, the best place to start this conversation is to go way back and review different numbering systems that we have. Okay, now this will not be an extensive list. I actually want to start at an unusual place for this discussion, and that is with integers. Okay, now within integers there are whole numbers and natural numbers. Okay, but think about integers as all the whole numbers that are both positive and negative, including 0. Okay, that's a good place to start because that's what you think about with numbers probably. Okay, whole numbers at least. Okay, within whole numbers, within integers, you can add and stay inside integers. Any, 3 plus 3 is 6. Any whole number plus a whole number will be a whole number. Okay, you can also subtract and stay within the positive and negative integers. Okay, you can also multiply, positives and negatives and still get integers. Okay, the problem comes when you begin to divide. Okay. You can divide like 9 divided by 3 and stay an integer, but most often, like 1 divided by 2 is 1/2. It's no longer an integer, which gives rise to another, larger numbering system that is called the rational numbers. Okay? The rational numbers are numbers that you can write as a fraction, like some value over value, like p over q. Now the rational numbers work really, really well because we can add, subtract, multiply, divide rational numbers and they stay rational. The problem comes in that there are some numbers that cannot be written as a fraction. Okay, numbers like pi, numbers like the square root of 2. Okay, numbers where you take square roots and you can no longer write them as a fraction of a whole number divided by a whole number. Okay, and these are called irrational numbers. Okay, and together the irrational numbers and the rational numbers gives us the real numbers. Okay, and so far everything you know about numbers have been within this real number system. Okay, you learned about integers, about fractions, you've learned about irrationals like pi and square root of 2. All the numbers that you're aware of are what are called real numbers. Okay. Now the problem with the real numbers comes in is that we can't take the square root of a negative number, like the square root of -9, for example. Okay, we don't have an answer for that. There is no number in the real number system that I could square to be equal to -9, because any number I have, negative or positive 3 would both square to be +9 and not -9. Okay, now that gives rise to imaginary numbers. So it's used. We call this 3i. We'll talk a bit more about that as we go on. Okay. My point right now with number systems is that surrounding the real number system is another numbering system that is called the complex number system. Okay, and these incorporate all of all the real numbers and all of these imaginary parts. Okay. And actually this, as far as I know, that the complex number system is everything we'll ever need, okay? As far as I know, any number can be written as a complex number, including real numbers, integers. They all fit within the complex numbering system, which put most simply, you have a plus bi. You have a real part, the a, plus a real number, b, times the number I, which is the square root of -1. Okay, so that's kind of to frame this whole conversation about complex numbers, is that there's this new numbering system that we'll need to use to handle the square root of a negative number. The next place to go is to talk about what is I. Okay, so I is the square root of -1, and that actually is really, really important when dealing with complex numbers. Okay, so the example I gave out earlier with the square root of -9, okay, and we know from factoring that, I have -1 times 9, and 9 is 3 times 3. 9 is actually a perfect square, okay, that I can write this as the square root of 3 times 3, which is 9, times the square root of -1, but we have decided that this lowercase I, we're going to stand for the square root of -1 because we use it a lot and because it's just simpler to write I as opposed to the square root of -1. So I get 3, and the square root of -1 is I. And so the number that if I squared it would be -9, that is 3i. Let me show you what that looks like, because I think that's useful right now in this discussion. So if I take 3i and I square it, then I'm going to square 3. 3 squared is 9, and I squared is something. Well, if worse comes to worse, you can remember that I is the square root of -1. Okay, and so this right here is the number that if I squared it would give me -1. If you square that number, you get -1. Or in other words, the square cancels out the square root, and you're left with -1. So we get -9. So that really is the number that if I squared it would give me -9. Okay, right here I want to do one more example where we're simplifying radicals that are negative. Let's look at the square root of -2,535. Okay, now if you want to review simplifying radicals, please see the previous video about simplifying radicals. Okay, now again, I'm going to use a factor tree, but the first line will be -1 and positive 2,535. Okay, now this 2,535 ends in a 5, so 5 must go into it, and if you divide by 5, you get 507. Okay, and then the digits 5 plus 0 plus 7 add up to 12, which is a multiple of 3, so 3 must go into this number, and so if you divide this by 3, you get 169, which I recognize as a power of 13. Okay, it's 13 squared. And so I have that pair and then these two other numbers. Okay, and so I'll use my shortcut of the pairs give me perfect squares because, anyway, and I get 13, the square root of what's left, which is 3 times 5. Okay, and don't forget the -1, and I have an I here outside the square root. So simplifying that one more step, I have 13 root 15i. All right, let's look at how to add, subtract, multiply, and divide complex numbers. So again, complex numbers are written in the form of a plus bi with a real number, in this case we're keeping it simple, so they're integers, plus another real number, I. Okay, so what you'll do is you'll add together, you think about I like a variable and you'll be fine. So you add together, well, first of all, you don't need the parentheses, so I'll just kind of drop the parentheses, okay, and I will combine together the real parts, so 3 plus 7 is 10, and combine together the imaginary parts, just as if I was a variable, because it is a variable. Okay, and 4 minus 20, if I have 4 i's and I take away 20 i's, then I have negative 16 i's, and that's what you get when you add together these two complex numbers. When you subtract complex numbers, it's very, very similar, except now I have a negative sign to deal with. I'll rewrite this 3 plus 4i, but I will distribute this negative as I take off my parentheses. So I get minus 7 and then plus 20i. Be very, very careful with this sign right here. A very common mistake is to mess up this sign right here, but you distribute the negative, and so that sign changes. Okay, and now it's just like adding. So I add together my real part. 3 minus 7 is negative 4. And I add together my complex, my imaginary part. So 4i plus 20i is 24i's. And there you go. Real part, imaginary part. It's a complex number. Now, how do you multiply complex numbers? Well, the same way you've been multiplying binomials. 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is plus 2i. And 2i times negative 2i, let's see here, is a negative 4i squared, which brings rise to a very important piece right here where we have I squared. I covered this a little bit earlier, but let's remember that I is the square root of negative 1, and so I squared must be the square root of negative 1 squared, which is negative 1. So if you ever see I squared, you'll plug in a negative 1 in for I squared. Let me just do that one step. Minus 4 times negative 1. So this negative 4 times negative 1 gives me a plus 4. At this point, I'll now just think of it like I'm adding together complex numbers. I add together the real parts. 1 plus 4 is 5. And in this case, the complex parts cancel out. And so we have just 5. Okay, so we go back and notice, hey, wait a minute, these are conjugates of each other, okay, which is another place that conjugates become in very, very handy. Okay, this video was introducing complex numbers. Thank you so much for watching.